All right, let's get right into it. Today, we are pulling back the curtain on the single piece of technology that powers almost every AI you interact with. We're talking ChatGPT, translation apps, you name it. We are breaking down the revolutionary architecture known as the transformer.
So, have you ever really stopped to wonder how an AI actually gets what you're asking? How it can write a poem or translate languages on the fly? Well, it's not magic. It's just some seriously brilliant engineering. And to understand it, we first have to look at the huge problem it was designed to solve. You see, before transformers came along, the AI world was all about something called recurrent neural networks, or RNNs. And they had this one fundamental speed-limiting problem. They had to process language one word at a time, in a straight line.
And this slide just shows you the problem perfectly. An RNN reads the, then it has to hold that in its memory to read cat. Then it holds that to read sat, and on it goes. Not only is this painfully slow, it's also just totally inefficient for modern computers that are built to do tons of things at once. But you know what? Slowness wasn't even its biggest flaw.
This right here is the killer analogy. An RNN is just like a game of telephone. It passes information from one word to the next, like whispering a secret down a line. And what happens in that game? By the time you get to the end of a really long sentence, the meaning of the first few words is fuzzy or it's just gone. The model literally forgets what it read at the beginning.
So clearly, the world needed a way to break out of this one-word-at-a-time prison. And this is where the huge breakthrough happens. It's all built on a single, incredibly powerful idea called attention.
This was the crazy question that changed the game. Forget the slow, sequential process. What if every single word in a sentence could look at every other word all at the exact same moment to figure out the context?
And that's exactly what attention is. It's basically a system that lets each word ask, okay, which other words in this sentence are the most important for understanding me? And then it creates a direct hotline to those important words, no matter how far away they are. And that's the crucial part. With attention, distance doesn't matter anymore.
This slide just nails the difference. The old RNN way was like trying to read a book one word at a time, struggling to remember the first chapter by the time you get to the last. The new way, with attention, is like absorbing the entire page in a single glance, instantly seeing how all the pieces connect.
So this new way of thinking unlocked three huge advantages. First, because you can process everything at once, you get this massive speed up. Second, it gives the model perfect memory. A word at the very end of a book can instantly connect to a word at the beginning. And third, and this is really cool, we can actually look inside the model and see which words it thinks are important.
Okay, so we've got this amazing concept called attention. Now let's do a quick tour of how it's actually built into the machine we call the transformer.
You can think of it like a four-step blueprint. First, embeddings. That's just a fancy way of saying we turn words into numbers. Then, positional encoding adds a little timestamp so the model knows the word order. Third, we have self-attention, the powerhouse engine we've been talking about that finds all the relationships. And finally, a feed-forward network chews on all that new info, letting each word think about what it just learned.
Now, the designers of the transformer figured, hey, having one expert look at a sentence is good, but what if we had a whole room full of them? So they came up with multi-head attention. And this analogy is perfect. It's like a committee of specialists, all analyzing the text at the same time, but each one has a different job.
So, for instance, one head might be a grammar expert, connecting subjects to their verbs. Another one is like a detective, figuring out that the word it actually refers to the cat from 2 sentences ago. When you put all these experts together, you get this incredibly rich, layered understanding of the text that one expert could never get alone.
And what's really fascinating is how this one powerful blueprint has been adapted to create different personalities of AI, each one fine-tuned for a specific kind of job.
The two most famous families are BERT and GPT. You can think of BERT as the understander. It looks at an entire sentence, forwards and backwards, to really nail down its meaning. That makes it great for things like search engines. GPT, on the other hand, is the generator. It only looks at what came before to predict the very next word, which is what makes it so amazing at writing stories, code, and, well, chatting.
This table really just lays it all out. You've got your BERT-style models that see everything at once to understand it. You've got your GPT-style models that only see the past so they can generate the future. And then you have models that combine both, which are perfect for tasks like translation, where you have to first understand a sentence in one language and then generate it in another.
Okay, so we have this incredible architecture.
But this is where the story gets really mind-bending. What happens when you just make it bigger, a lot bigger? This brings us to the wild world of scaling.
1.76 trillion. That's the estimated number of parameters or a sort of digital knobs in a model like GPT-4. I mean, just to put that into perspective, the human brain has around 100 trillion connections. We are operating on a truly astronomical scale here.
But a number like that begs the question, why? Why go so big? Is it just about getting slightly more accurate answers, or does something fundamentally different start to happen when you add all those zeros? The answer, it turns out, is a definite yes.
And this is where the magic comes in. At a certain size, completely new abilities just emerge. Things smaller models just can't do. Suddenly, these massive models can learn a new skill from just one or two examples, or they can reason through a problem step by step. And the wildest part is, nobody programmed these skills in. They are a pure byproduct of scale itself.
So to wrap this all up, this is the best way to think about it. A transformer is like a massive library where every single page can instantly see and reference every other page. The attention heads are like these super intelligent readers who can absorb and connect all of that information at once. It's this ability to see everything, everywhere, all at once that makes the transformer the true engine of modern AI. And it just makes you wonder, what new abilities are going to emerge as these libraries keep getting bigger?